Let's study what happens when we apply a GL2 element to this vector kappa 1, 1, which we just constructed, which was this linear combination here, and each of these here was an element of a product basis. Recall also that G was our shorthand notation for the representation of GL2 on the tensor product, which was just multiplication with G itself in each of the factors. So this means that if we apply G to, say, 1, 1, 2, that's the first thing we have to do here, we get linear combination of other product basis elements I, J, K are right here, and let's say GI 1, GJ 1, GK 2, and summation over repeated indices over I, J, and K. So if we do this here, then we really get, let's say, IJK, and then 2 times what we just wrote, GI1, GJ1, GK2. So this is from the first term here. And now we apply it to this one here, and that's minus GI2, GJ1, GK1. And from the last term we get GI1, GJ2, GK1. Okay, and we said summation over I, J, and K, each from 1 to 2. So this is a sum of 8 terms. And now we really have to spell these terms out. So for example, there is something that's proportional to 1, 1, 2. And in that case, so I is 1, J is 1, K is 2. So now we have twice G11, G11, G22 minus G12, G11, G21 minus G11, G12, G21. So these are all matrix elements of our GL2 matrices. Okay, what happened here? There is at least one G11 in each of these terms here. Here's a G11, here's a G11, and here's a G11. Now when we look at these last 2 terms, they are actually the same. So we get twice this term, as we also got a factor of 2 here. And now look what's left in blue. That's just the determinant of our GL2 matrix G. So what we really get here is twice matrix element G11, it's the orange stuff, and then the determinant of G. Okay, what's the next term? There is one term, let's say, proportional to 2, 1, 1. That's twice G21, G11, G12 minus G22, G11, G11 and minus G21, G12, G11. And again, we have a G11 in each term. So there is one here, there's one here, and one here. And this time the first term and the last term are identical except for the prefactor. There's a 2 here and a -1 here. So we keep this term just once. And then what remains is again the determinant of g here in blue. So this time there is no factor of 2. But this time we get, let's say, minus g11, because here's the first term from the determinant times the determinant of g. Okay, and now try this for the remaining terms, or trust me on that. What we find are these additional terms here. They are all of this kind. There's a determinant of g hiding, and then some element of our matrix G here. Good. And there are 6 terms, by the way, which I wrote here. 1, 2, 3, 4, 5, 6. But I said that there are 8 terms. So where are the remaining 2 terms? Well, there is nothing proportional to 1, 1, 1 or to 1, 1 or to 2, 2, 2, because if we insert 1, 1, 1 for each of the indices, here, 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 then the whole thing vanishes. And the same for 2, 2, 2. So there are only 6 non-vanishing terms here in this sum. And now something nice happened, because if you look at these first 2 terms here, this times this times this, and then this one here, well, they all have a G11, and then what we really got is this linear combination here again. The 1, 1, 2 comes with a prefactor of 2, and then the 2, 1, 1 and the 1, 2, 1. So what we really got, if we spell this out here, is we got the determinant of G times this vector kappa 1, 1 again, and then there was this additional factor G11, one matrix element of our GL2 matrix. And the same is true for the remaining 3 terms. They give the other vector, which we haven't written down here, the kappa 2, 1, the other element of this invariant subspace we're just considering right now. So what we find here is plus, let's say, kappa 2, 1, and this is multiplied with a minus G 2, 1. Okay. And always this determinant factor here. Now we can do the same thing for this other basis vector, and I will not spell this out, but you can try at home if you like. And we find a similar formula. We find that G applied to kappa 2, 1 is also a linear combination of this kind with a det determinant, prefactor, and some matrix elements. And of course the structure has to be like this because it's an invariant subspace, so we have to get linear combinations of these 2 vectors again when we apply our G. But now this means that we can also read off from the orange part here our representation matrix. The representation matrix is just the orange stuff and this determinant here, and it's almost, the matrix part here is almost the original GL2 matrix, except for the additional minus signs here.